Okay, so basically it's called common ion effect. Common ion effect, okay? You take down the title first, I show you the diagram which is already printed for you. This one is really simple, not difficult, not difficult. Okay, then you want me underline this in red or highlight also can. Common ion effect basically, right, okay, have one conclusion. Basically, the solubility of a salt will decrease and your objective is to prove that this statement is correct. Proving can be in terms of calculation form or can be in terms of explanation. All right, let me explain what is difference. Okay, I zoom into the diagram that you all had first. This is the diagram, right? Okay, this is a diagram. Okay, first experiment, okay, I dissolve maybe 1 gram of calcium sulfate salt, right, solid salt into water. Second experiment, I dissolve the same mass of calcium sulfate in the same volume of solvent, but this time round, the solvent is no longer pure water, it is actually calcium nitrate. And can you see I underline Ca? So you're dissolving calcium sulfate in a solution that contains identical ions. In this case here, it is Ca2 plus. So this is called common ion effect. Wherever you dissolve a salt into a solution that contains identical ions, the ions can be cation or anion, right? This is called common ion effect, and it always cause the solubility of this one here to be lower than water. Okay? Yeah, so this is given to you, right? Okay. Then, so this is the scenario over here. Zoom out. Okay, so let's say for example you are given 0.1 mole per gm cube calcium 2 plus present in the solvent already. So the solubility of calcium sulfate in water, I let it be A mole per gm cube. Definitely is larger, higher than the new solubility of the calcium sulfate in a solvent that contains identical ions. In this case, Ca2 plus. So for example, I let this be X. So A always higher than X. A always higher than X. Your job is just to prove this is true. Proving. So this question is more like proving because it's a known fact that due to presence of common ion, the solubility of the salt will always decrease when you compare to dissolving the same amount of salt in pure water. Okay, okay, I'll pause. Latita, so far okay? Can so this is called common ion effect. It's more like a proving questions. I already tell you that the end result is solubility decrease. You prove it. You still want? You want to immediately drop the paper?
Can't use speakers, very loud.
I don't know whether but they should be done by 8.
Oh.
Anyway, they are moving out by, I think, end of March or something like that. So they are not renewing the, yeah. So how do we know? Because actually, the landlord contacted us, said, do you want to rent the place? Then I said, we got another place actually. So we didn't have it. Oh, I saw your daddy and mommy on Saturday.
I saw
yeah, but then your brother go home himself.
Yeah.
Yeah. But I did check, I said that, do you have enough money in your fare card? Okay, come. All right, so proving, like what I mentioned, is more like a proving case, right? Okay. Now, how to prove? Prove by calculations, okay? So we start by writing out the equilibrium equations. Calcium sulfate give you whatever ions, okay? Instead of going through the entire ice table, can you see I zoom down to the last step here, equilibrium. I repeat, instead of the full ice table, you just need to present to me at equilibrium. You skip initial, skip change. Just zoom into this one here. And the same is always a very standard way of doing here. Okay. So at equilibrium, your calcium 2 plus, I let the new solubility rate of calcium sulfate in the common ions solution be X here. So X1 is to 1X, right? Then sulfate will be X. But because the original solution here, calcium nitrate, already contained 0.1 mole per dm cube Ca2 plus, so I need to add 0.1 here. So far, okay? We're going to make an assumption over here. All right. We'll assume that x is way smaller than 0.1. So this entire 0.1 plus x can be rewritten as just 0.8. So we make this assumption here created. Can see? And then after that, you sum in 0.1 and your x for sulfate into your KSP expression. Then we solve for x because KSP value should be and will be given. You understand? So, my KSP, right? My KSP equals to calcium 2 plus, SO4 2 minus. This is given. So this is 0.1, then you x. Then you solve for x. Something like that. Okay, something like that. Here's the value had to be given to you in the question here. Calcium 2 plus is something as 0.1. Sulfate is something as x. Then you solve for x, that's all. Okay? So that is proving that solubility indeed decreased by calculations. Okay? So the question will tell you whether they want you to explain it or by calculations. Okay? So it's very straightforward. All you have to do is able to identify that this is question type 2A because there are 5 subtypes under question type 2. Okay?
For given solubility, common ion effect, always assume that the amount given is much more than the,
What do you mean?
like your x.
Oh yeah, okay. Usually we always make this assumption here unless the question stated otherwise. And most of the time, we always assume that this is a valid itself. Yeah.
But for exceptions, they will say like what?
So far, I only see one exception before in terms of MCQ, and we can add because MCQ we can see the value in the option now. So on the option shown in MCQ is shown that the particular x value don't differ too much from 0.1. Then we don't do the assumption. But so far for structured questions, at least for the Cambridge question that I've seen so far, right, it's okay to make the assumption. But of course, if you feel that you can use your graphic calculator, you can use your calculator to do it even without assumption, you go ahead. Yeah. Okay. All right. Last but not least will be this. Okay. So sometimes the question will say, okay, explain. When you see the word explain, then you bring in like what Matthew just now said, LCP, Le Chatelier principle, right? Okay. So that principle state whenever equilibrium reaction is at dynamic equilibrium, if you do something to disturb equilibrium, the POE will shift to counteract change, right? So all you have to do is just state this phrasing here by LCP, comma, presence of common ion. So you have to state for me what is the common ion. State the common ion, right? Causes the equilibrium. So in this case here, this is the external here, by the way. So you have to draw out the equations as part of the answer so that Cambridge know which equilibrium you're talking about. Okay? Causes the equilibrium to shift left, backward, to form more of the calcium sulfate. In a way, solubility dropped. That's all. Okay, ma? Ken? Easy,
Reasoning.
If the question say explain,
There'll just be
this just this. So sometimes the question say calculate to show that solubility decrease, or to calculate to prove the effect of common ion. So it really depends on you see the question what they want. Okay, this is okay, very easy, very common, very popular. So far can accept